This call is now being recorded.
This
Hello
call is
students,
now being
good
recorded.
morning. Welcome to our subject Airport and Bridge Engineering, and today we will take some presentations on airport, bridges and similar topics. Over to Maneshwar.
Hey, double
Maneshwar, you can start.
Ah. Introduction to airports. Airports are important transportation hubs for travel and they provide facilities for aircraft taking off, landing, and various operations for passenger movements. And airport classification help engineers design for a safe and efficient airport. Classification also determine runway, length, width, and geometric standard required. Function classification of airport. It is categorized based on their role and services. It identifies the type of traffic handled by airport, and it also determines infrastructure requirement and passenger capacity. Uh, there are types based on function: international airport, domestic airport, regional airport, cargo airport, and military airport. First, international airport. It handles flights between the country to country. It provides custom and immigration and international passenger facilities. Have long runways and advanced navigation system. For example, Delhi Airport, Mumbai Airport, and Bangalore International Airport. Second, domestic and regional airport. The domestic airports have certified flights within a country. Regional airport connect smaller cities, and these airports usually handle the smaller aircraft and light traffic. Third, airport classification based on their standards. It is classified on aircraft size, runway requirements. These standards determine runway length, width, taxiway, and safety areas. Geometric standard ensure safe aircraft operations. There are runway length from ICAO code number. First code number is for less than 800-meter length. Second, between 800 and 1200. Third, 1200 and 1800-meter, and fourth, more than 1800. Or for aircraft wingspan, code A for 15-meter, more than 50-meter, code B between 15 and 24-meter, code C between 24 and 36-meter, code D between 36 and 52-meter, code E 52 and 65, and F between 65 and 18-meter. Uh, Conclusion: airport classification help in proper airport planning. Function classification define the role of airport, and geometric standard ensure safe aircraft movement and operation. And these both classifications are essential for modern airport infrastructure. Thank you.
Okay, good. व्हिडिओ ऑन करा जे प्रेझेंट करतायत त्यांनी म्हणजे आपल्याला लक्षात येईल आणि रोल नंबर सांगा.
74.
येस, नेक्स्ट. लाईन मध्ये ओळीने प्रेझेंट करा सो दॅट देर विल नॉट बी वेस्टेज ऑफ टाइम. ज्ञानेश्वर, युअर अटेंडन्स इज मार्क.
तर मग लिव्ह केलं तर चालेल का?
Yes, yes, you can leave or you can watch other presentations.
हॅलो,
Yes.
स्क्रीन दिसते का?
हो, रोल नंबर सांगा.
34.
रोल नंबर आणि नाव.
क्षीरसागर अभिषेक.
व्हिडिओ ऑन करा.
सर लाईट ऑफ येते, काही दिसणार नाही.
असू दे, सगळ्यांसाठी कॉमन इन्स्ट्रक्शन सांगितलं मी. ठीक आहे, बघा. चालेल. ओके.
Introduction. Airport marking and lighting are visual aids used at airports
स्क्रीन
to
गेली
guide
बरं का?
passengers and ground vehicles during aircraft movement. They are very
स्क्रीन
important
स्क्रीन
for.
स्क्रीन शेअर कर परत.
दिसते का?
हा,
The introduction. Airport marking and lighting are
प्रेझेंटेशन ओपन
visual.
कर. प्रेझेंटेशन ओपन केलंय.
Airport marking and lighting are visual aids used at airports
अभिषेक,
to guide. Hello.
हा तू पूर्ण विंडो शेअर केली का काय केले? कारण की ब्लँक दिसते स्क्रीन.
नाही, फक्त PDF शेअर केले.
नाही नाही, शेअर करताना विंडो शेअर करायची आणि पीपीटी ओपन करायची, म्हणजे जे काही मोबाईलच्या स्क्रीनवर किंवा लॅपटॉपच्या स्क्रीनवर आहे ते दिसतं.
दिसतंय का आता
हां,
सर?
येस येस.
Introduction. Airport markings and lightings are visual aids used at airports to guide pilots and ground vehicles during aircraft movement. They are very important for safe takeoff, landing, and taxiing, especially during night operations and low visibility conditions. They help pilots identify runways, taxiways, aprons, and other operational areas. Objective to guide aircraft safely on the ground, to assist pilots during takeoff and landing, to improve safety during night operations, to reduce chances of runway accidents, to help pilots during fog or bad weather. Airport payment and marking are painted signs and lines on the surface of runways, taxiways, and aprons. These markings helps pilots identify different areas of airport and follow the correct path. Main type of airport markings: runway markings, taxiway markings, apron markings. Runway marking. Runway marking are white color marking painted on the runway to help pilots during landing and takeoff. Types of runway marking. Runway designation marking shows the runway number. Number represent the magnetic direction of runway. Example, runway 9 means direction 90 degree. Runway center line, dashed white line in the middle of runway, helps pilot keep aircraft aligned. Third side marking indicates beginning of the landing area of runway. Touchdown zone marking shows the area where aircraft should land. Runway edge marking, white lines along both sides of runway. Approach lighting system. Approach lighting system helps pilot during landing. It consists of a series of lights placed before the runway threshold. Functions helps pilots align aircraft with the runway, improve visibility in fog or rain, guides aircraft safely during approach. Advantages improve aviation safety, helps pilots navigate easily, enables night operations, reduce accidents, improve aircraft efficiency. Conclusion. Airport markings and lightings are essential components of airport infrastructure. They help guide pilots and ensure safe aircraft movement during takeoff, landing, and taxiing. Proper marking and lighting systems are necessary for safe and efficient airport operations. Thank you.
ओके, नेक्स्ट. नाव सांगा, रोल नंबर सांगा. श्रीनिवास. वेळ वाया घालू नका. वन बाय वन पटपट पटपट प्रेझेंट करा, तरच मी अटेंडन्स लावणार आहे. जे प्रेझेंटेशन देतील त्यांची अटेंडन्स लागेल फक्त. स्क्रीन दिसते श्रीनिवास? प्रेझेंटेशन स्टार्ट कर. तू अजून बोलला नाहीस बहुतेक, काही आवाज नाही आला तुझा.
आवाज येईल सर.
हा, येतोय आवाज, बोल. चालतंय.
Good morning, everyone. So my topic is about airport stuff, which equipments and fires. So equipments and fires are one of the most important structural part of aviation. Hello, hello.
यस यस कंटिन्यू कर.
आवाज यायला सर?
हो हो आवाज येतोय. कंटिन्यू कर, स्क्रीन पण दिसते.
बरं बरं. So what is bridge substructure? Bridge substructure is the portion of a bridge below the bearings that transfers the load from the substructure to the ground. So the main uh, components of the substructure of the bridge are abutments, piers, wing walls, and foundations. So in this slide number 5, you can see that what are piers. The substructure that the ends of the bridge, they are known as abutments, or a bridge abutment is a structural component provided at the end of a bridge. It supports the superstructure such as the deck, girders, and slab, and safely transfers all the loads to the foundation and ground. In addition, it acts as a retaining wall for the approach embankment. So, functions of a bridge abutment are: it supports the dead load of the bridge superstructure. It carries live load due to vehicular traffic. It provides a smooth and safe transition between roadway and bridge deck. The components of a bridge abutments: abutment cap, stem, that is wall, bearing seat, wing walls, and foundation. There are different types of bridge abutments. Then loads acting on bridge abutments: dead load, live load due to traffic, earth pressure from backfill material, wind load acting on bridge deck, seismic forces in earthquake zones, water pressure and uplift forces. And materials used in abutments: plain cement concrete, that is PCC, reinforced cement concrete RCC, stone masonry, pre-stressed concrete in modern bridges. Important of bridge abutments: it ensures stability and durability of the bridge. It improves ride quality and user comfort, reduces maintenance and increase service life, and last is plays a crucial role in structural safety. And the next component of the bridge is piers. In this image, you can see the piers. Piers. A bridge pier is an intermediate vertical support provided between the two ends of a bridge. It supports the bridge superstructure and transfers all loads safely to the foundation and ground. Piers divide the total bridge length into smaller spans. Functions of a bridge piers: supports the dead load of the bridge superstructure. It carries live load due to vehicular traffic. It reduces the effective span length of the bridge. It provides stability to the bridge under water flow and flood conditions. Components of a bridge pier: pier cap, pier shaft, bearings, foundation, and cutwater if it is provided. Then types of bridge piers: solid wall, column pier, pier bend pier, hammerhead pier, and trestle pier. Loads acting on bridge piers: dead load, live load from vehicles, wind load, seismic forces, water current, and wave forces, impact due to floating debris or vessels. Materials used in bridge piers: stone masonry, plain cement concrete, RCC, that is reinforced cement concrete, pre-stressed concrete, and steel, that is in rare case we use steel. Importance of bridge piers: they provide intermediate support to long bridges. They reduce material requirement in superstructure. They improve structural efficiency. They ensure safety during floods and earthquakes. And last point is, what is the difference between pier and abutment? Pier supports bridge or at intermediate points, whereas abutment support bridge at ends. Piers do not retain soil, abutments retain earth. And the last point is, piers are subjected to water forces. Abutments are not subjected to water forces. That is, abutments are connected to the ground. Thank you, sir.
Nice presentation, Srinivas. Good.
Presentation topic is temporary bridge and introduction. Temporary bridge engineering structure built to provide short crossing solution of obstacles such
स्क्रीन
as
नाही शेअर झाली बरं का स्क्रीन. आणि तुम्ही लांब लांब बसा म्हणजे इको येणार नाही. दिसली होती स्क्रीन आता. सिलेक्ट विंडो करायचं आणि पीपीटी ओपन करायचं.
Topic is temporary bridge introduction. Temporary bridge are engineered structure built to provide short-term crossing solution over obstacles
हा येस.
such as rivers, valley, construction sites. They are indispensable for maintaining vital access and transport continuity in variation sensors used extensively during large-scale construction projects, critical for emergency response and disaster relief operation, provide access when permanent bridges are under repair or unavailable. Why use temporary bridge? Temporary bridge used for rapid development, minimal impact, also cost effective. Common material for temporary bridge. Uh, Timber, a traditional widely available material, praised for its environmental friendliness and ease of use. Steel, valued for its immense strength, durability, and high reusability in various bridge design. Composite material, advanced material offering enhanced strength to weight ratio and longevity. Engineered lumber, modern timber products providing superior performance and design flexibility. Timber in temporary bridges. Timber remains a popular choice due to its properties and adaptively. It's often used in the form of mats or planks for rapid assembly on site. Preferred timbers, hardwoods, hardwoods such as oak and dot toggles fire are favored for their robust, robust nature. Advantages: lightweight, easy to transport, and causes minimal site disturbance during installation. Challenges: susceptible for to root and decay if not properly treated, and typically has lower load-bearing capacity compared to steel. Floating bridges, Pontoon bridge defined. Pontoon bridges are unique classes of temporary structures supported by beyond pontoons or purpose-built to boats rather than traditional fixed piers or foundation. They are ingenious solution for spanning vast or deep bodies of water. Their constructing conventional foundation is either impactive, pier, or cost prohibitive. How Pontoon bridges work: beyond model consists of modular sections that float on purpose-built beyond support designed to handle significant load. Interconnected roadway. These individual sections are securely connected to form a continuous and stable roadway for traffic. Rapid deployment, designed for swift assembly and disassembly, making them ideal for time-sensitive operation. Adaptable, can be adjusted to suit varying lengths and load requirement. Advantages and limitations of Pontoon bridge. Advantages: quick installation, minimal construction time, ideal for rapid response. Adaptable, naturally adjust to function in water level, ensuring continuous usability. Reusable, components can be recovered and redeployed for future project, offering excellent value. Deep water solution, bypass the need of costly and complex deep water foundation. Limitation: load bearing capacity, generally have lower load limits compared to fixed bridges. Environmental factor, susceptible to strong water currents, winds, and severe weather, which can affect stability and safety. Maintenance, require ongoing monitoring and maintenance to ensure balance and structure integrity. Aesthetics, often functional in design, not intent for long aesthetic integration. Summary of temporary bridge at a glance. Versatile solution. Temporary bridges are vital for emergency construction and remote access need, providing critical connectivity when permanent solutions are not feasible. Material choice. Timber and steel serve a primary construction material, each offering unique benefits and suited to different application and environmental conditions. Water crossing, pontoon bridge provide flexible and rapid solution in water crossing, particularly where traditional fixed support are impractical or impossible to build. Future exploration, understanding these fundamental aspects sets a stage for a deeper exploration into engineering, deployment, and future innovation in temporary bridge and technology.
Yes, good presentation, yes. नाव आणि रोल नंबर सांगा.
Uh, Good morning, friends. My name is Rohan Jitendra Andekar, roll number 69. My topic name is Word Air Transport and Airport Layout. Air transport stands for the firstly power of the airport transport. Air transport stands for as the fastest mode of transportation for long distance travel and connecting contents for mere hours. This remarkable capability has transformed our world, enabling unpredictable levels and international trade of global tourism and economic development across the nations. Key roles of a- aviation in the global economy. First, international trade enable to rapid movement of high value and time sensitive cargo across borders, supporting global supply chains. Global tourism connecting the travelers to destinations worldwide, driving tourism industries and cultural exchange. Economic development create jobs, stimulates the regional growth, and serve as infrastructure backbone of the emerging economics. Geographical concentration of air transport. Air transport infrastructure is distributed unevenly across the globe with significant concentration in economically developed the regions. The disparity reflects the variations in population density, industrialization levels, economic prosperity, and the tourism demand. Major aviation regions, first North America, USA, and Canada dominate with the highest passenger and cargo traffic volume globally. Second is Europe, features an exponentially dense network of the international airport with high short haul traffic. Asia Pacific, the fastest growing regional globally major hubs in China, India, Japan, and Singapore are expanding rapidly to meet shoring the demands. Emerging and developing aviation markets, uh, first Middle East global transit hubs like Dubai, Doha, and Abu Dhabi uh, leverage the strategic geographic positioning between the Europe and Asia. Latin America, experiencing the moderate growth with major aviation centers, Brazil and Mexico. Africa, understanding the airport layout. Airport layout refers for the strategic arrangement of the critical components, including runway, taxiway, terminals, hangars, and support facilities. A well-designed layout ensures safe and efficient aircraft movement, minimize delays and congestions, uh, streamlines the passengers processing. Characteristics of effective airport design. First, proper runway orientation. Runway must be aligned with prevailing with direction, minimize the dangerous crosswind effects during the takeoff and landing operations. Adequate runway length. Length required depends on the aircraft type, airport elevation, and temperature. Efficient taxiway system. Design enables smooth direct aircraft movement between the runway and gates with prevailing runway congestion and reducing ground delays. Well-planned terminal areas and safety and obstruction clearance. Terminal design and balancing of flow. First, zoning principle. Modern terminals separate operations into distinct functional areas to optimize the both of security and passenger experience. Effective terminal design consider passenger comfort, operational efficiency, and security requirement while maintaining flexibility and technological upgrades and capacity expensive. Connecting the world through aviation. The world air transport remains concentrated in developed economically strong regions, is continuous expanding into the emerging markets. Airport layout and design plays critical role in the ensuring safety, operational efficiency, and the capacity to meet growing the demand. Thank you.
Okay, good, Rohan. Next.
Hello.
Yes, Nikhil.
Sir,
नाव आणि रोल नंबर.
screen दिसते sir.
PPT ओपन केल्यावर दिसेल. Yes.
Good morning, sir. My name is Nikhil Dabade, roll number 72. Introduction to overview of Delhi Airport. Indira Gandhi International Airport is the primary international gateway to India and one of the busiest airport in the world. It serves as a major aviation hub for passenger and cargo operations. The airport operates under advanced aviation infrastructure, modern air traffic management systems, and world-class terminal facilities. Location: New Delhi, India. IITA code DEL, ICAO code VIDP. Operator: Delhi International Airport Limited. Airport classification and standards. Delhi Airport is classified as international commercial airport operating under ICAO Annex 14 standards. Airport Authority of India regulations. DGCA aviation safety compliance category triple IB instrument landing system ILS. The airport supports wide body aircraft such as Airbus A380 and Boeing 777, making it capable of high capacity international operations. Runway infrastructure. Delhi Airport has three parallel runways designed for heavy aircraft operations. Runway 11R 29L 4433 meters primary runway. Runway 11L 29R 3810 meters. Runway 1128 381 meter, 3813 meters. Technical features: CAT triple IB ILS for low visibility operations, advanced runway lighting system, high strength pavement for wide body aircraft, rapid exit taxiways for efficient aircraft movement. Passenger terminal facilities. Delhi Airport operates three major terminals. Terminal 1, domestic low cost carriers. Terminal 2, temporary domestic operations. Terminal 3, integrated international and domestic terminal. Terminal 3 features annual capacity 40 plus million passengers, automated baggage handling system, aerobridge and contact stands, self check in kiosks, smart security screening, air traffic management system. Delhi Airport uses advanced air traffic management system, radar-based aircraft surveillance, automatic dependent surveillance, broadcast ADS-B, instrumental landing system, surface movement radar, precision approach radar. These systems ensure safe aircraft landing, takeoff, and ground movement. Navigation and aviation safety. The airport includes VORDME navigation aids, approach lighting system, runway centerline lighting, emergency response and fire rescue services. Category 10, aviation security under BCAS standards. These systems maintain operational safety even during low visibility conditions. Cargo handling infrastructure. Delhi Airport is a major cargo hub in South Asia. Facilities include dedicated cargo terminals, cold storage facilities, automated freight handling, customs bonded warehouses, and perishable cargo centers. Annual cargo handling capacity exceeds 1 million metric tons. Thank you.
Thank you, Nikhil. Good presentation.
स्क्रीन दिसते.
प्रेझेंटेशन ओपन कर. स्क्रीन दिसते. येस. रोल नंबर काय तुझा?
रोल नंबर 86.
ओके.
Good morning, everyone. My topic is type of bridges. Understanding fixed span bridges. Fixed span bridges form the backbone of modern infrastructure connecting communities and enabling transportation across obstacles. These structures feature span that are fixed between supports using pier and abutment to transfer load safely to the ground. There, they serve as a essential link for roadway, railway, and pedestrian pathway engineered to carry vehicle, train, and people with reliable and strength. Simple bridge, like the foundation. Basic design principles. A simple bridge consists of a single span support at two ends, making it the simplest and most common bridge type. The straightforward design is ideal for shorter distance and is both easy to design and construct. The simplicity translates to cost effectiveness and reliability, which is why this is type of appearance everywhere from rural footpath to urban roadway. Continuous bridges, extended reach, multiple support, more than two support create stability across extended distance. Continuous deck, the deck flow seamlessly over several span without breaks. Reduce the stress, distribute bending forces effectively, improving overall strength. Cantilever bridges reaching cut. Single end support. Beam are supported only at one end, extending outward. Paired arms. Two cantilever arms extended from pair toward each other. Central connection. Arm meet in the middle, creating a complete span. This innovative design suit medium to long span, particularly across wide river. The balance of forces create a stable structure capable of supporting heavy load. Arch bridge, timeless strength. Compression excellence. Arch bridge features a curved arch shape that transfer load through compression forces to the support. The ancient design remains one of the strong and most stable bridge type. Materials range from traditional stone to modern steel and concrete, adapt, adopting the timeless arch principle to contemporary needs. Excellent load distribution, long lifespan with minimal maintenance, aesthetic appeal combined with strength. Suspension bridges, engineer marvels, main cables, deck suspended from thick steel cable, tall tower, cable pass over towering support, secure archers, cable archers at both end, suspension bridge on curve, the longest span ideal for sea crossing and deep valley. The flexible design absorb wind and seismic forces while supporting massive weight. Bowstring girder bridge. Unique structure. The bridge type features a curved top chord and straight bottom chord, with the bottom tie restraining outward forces. The distinctive bow-like shape provides excellent strength of medium span. Commonly used in railway bridges, this design efficiently handles the heavy concentrated load from trains. The curved top distributes forces while the bottom chord prevents spreading at the support. Rigid frame bridges, integrated design, rigid connection, deck and supporter join on a single unit without separate bearing. Frame action, load transfer through the frame structure, creating balance forces. Span range, ideal for short to medium span with efficient material use. The integrated design reduces the number of components, simplifying construction and maintenance, commonly in highway interchanges and urban setting where space is limited. Cable stayed bridges, modern elegance, direct cable supported, bridge deck, bridge deck directly to tower Y cable, eliminating the need for main suspension cable. Pattern variation, cable
राहुल एक मिनिट थांब, स्क्रीन प्रेझेंट करू नको, चालू प्रेझेंटेशन होऊ दे.
Cable creates striking fan or sharp pattern, combining functionality with visual appeal. Contemporary design, strong modern solution for long span with faster construction than suspension bridge. Bridge materials, the building blocks. Superstructure material determines strength, durability, and span capabilities. Each material offers unique advantage for different bridge type and requirement. Steel, high strength to weight ratio with excellent flexibility and ductility, ideal for longer span and seismic zones. Reinforced concrete, strong and durable with good compressive
संकेत
strength
स्क्रीन
even.
पुन्हा शेअर कर एकदा.
Okay, sir. Sir, this is screen.
हो हो. ओके पीपीटी ओपन कर. ओके.
Bridge materials, the building blocks. Superstructures material determines strength, durability, and span capability. Each material offers unique advantage for different bridge types and requirements. Steel high strength to weight ratio with excellent flexibility and ductility, ideal for longer span and seismic zones. Reinforced concrete, strong and durable with good compressive strength, cost effective for medium span and easy to maintain. Pre-stressed concrete, pre-tensioned cable create a compression, enabling longer span without cracking. Common in railway bridges. Composite materials combines steel and concrete for optimal performance. Steel provides tension strength while concrete handles compression. Thank you, sir.
ओके. गुड.
सर लेफ्ट झालं तर चालेल ना?
हो.
स्क्रीन दिसते का सर?
हा प्रेझेंटेशन ओपन केलं दिसेल लगेच.
हा दिसतंय का?
हो येस.
Everyone,
नाव आणि रोल नंबर.
good morning everyone. My roll number here 105. Presenting tough moment on ground and during approach. First, runway markings. All runway markings are painted white. These are six types of markings called threshold, which is five strips marking where landing begins. A designation number, magnetic heading divided by 10. Example, runway has 27 faces, so it's 27 degree. Center line, a dashed white line guiding pilots during takeoff and landing. A touchdown zone, which is rectangular strips extending 900 meter from threshold. Aiming point, two large marks among 300 meters from threshold, pilot's visual target. Displays threshold, yellow arrows where landing is not permitted. Second is taxiway marking. Taxiway markings are yellow. The center line is continuous yellow line. The most safety critical marking is the runway holding position, which is two solid plus two dashed yellow lines. Pilots must stop before the solid side and never cross without ATC clearance. Third is approach lighting system. ALS guides pilots from instruments to visual contact during final approach, extending 900 meter from the threshold. This system includes ALSF 1 by 2, which is high intensity used for CAT1 to CAT3 ILS. MALSR, which is medium intensity standard CAT1 runway. Third is ODALS, which is five flashing lights, basic non-precision guidance. Third is fourth is REIL, which is two flashing lights identifying the runway and quickly. Fourth is runway. For the runway lighting, runway lights use color coding for pilot awareness. Green, which is used for threshold lights, safe to land sides. Uh, Second is white edge lights along the runway. Third is yellow, last 600 meter of edge lights, warning zone. And red is runway and runway end lights, which is stop zone. Fifth is fifth is PAPI and VASI. These are glide slope indicators. They tell the pilot if they are on the correct approach angle or not. PAPI has four lights, two white and two red. On slope, all white are is equal to too high, all red is equal to dangerously low. VASI uses two bar rows, upwind plus downwind red on glide path. Airfield science. Airfield science follow the simple color route. White on red, mandatory. Runway is equal to no entry. So must obey. Uh, Second is black on yellow, location sign, and yellow on black, which is direction or designation, destination sign. So to summarize everything, white markings for runway, yellow for taxiway, color-coded lights for positional awareness, and red signs for mandatory instructions. These systems together ensure zero error aircraft movement in all weather conditions. Thank you, everyone.
Good. Prem Moite, nice presentation, nice content.
I think
This call is now being transcribed.
सर मी करू का?
हो चला नाव सांगा, रोल नंबर सांगा आणि सुरू करा प्रेझेंटेशन. पीपीटी शेअर करा.
सर विजिबल आहे का?
हो. तुझा रोल
Good
नंबर.
morning, sir. I'm Kshitija Piglikar. My roll number is 10. I'm talking about my topic that is Trivandrum International Airport. Trivandrum International Airport, that is the international airport serving the capital city of Kerala. It is established in 1932, one of the oldest operational airports in India. It operates domestic, international, and chartered flights, strategically located near the southwest coast of India, close to the urban sea. Acts as a major gateway of the Middle East and Southeast Asia sectors, plays an important role in regional economic development and urban growth, demonstrates the application of the airport planning uh, principles, capacity analysis, and passenger uh, terminal design. The project background.
Meeting is
Uh,
publicly streamed.
Established in 1932, making it one of the oldest operational airport in India, initially developed to serve the kingdom and early regional air services, later taken over the systematically expanded by Airport Authority of India. It continues the growth in domestic international tourism and Gulf traffic created the need of the large scale modernization. In 2018, operations were transferred to Adani Group under the PPP model of long term development. Development includes near terminal facilities, runway and apron straightening, and navigation upgrades. The design architecture. In this, modern functional planning, terminal layout flows international airport standards with proper zoning of departure, arrival security, commercial and services areas to ensure smooth and safe passenger movement. In structural and architectural system, use of RCC and steel long span structures provides wide column free spaces, high roofs, and flexible interior suitable for large passenger volumes in climates and responsive and sustainable design. Design incorporates natural lighting, ventilation, energy efficient systems, and corrosion resistance material suitable for the coastal environment. The capacity and operation. Passenger handling capacity designed to handle a growing volume of domestic and international passengers with terminals planned for peak hour traffic, efficient in checking, security and baggage processing, aircraft movement and airside operations. In this, runway, taxiways, and aprons are planned to support safe takeoff, landing, parking, and ground handling of narrow body and selected wide body aircraft. Movement and airside operations, runway, taxiway, and aprons areas are planned to support safe takeoff, landing, parking, and ground handling of narrow body and selected wide body aircraft. The runway. A runway includes the primary paved runway supporting domestic and international aircraft operations, pavement designed for heavy aircraft loads and frequent movements, taxiway and aprons planned for safe aircraft circulation and parking, equipped with lightning markings and drainage and navigational aids for all weather operations. The terminal. The modern terminal buildings designed to handle domestic and international passengers, planning based on efficient passenger flow with separate arrival and departure zones. Facilities includes check-in counters, security screenings, baggage handlings, and retail areas. The design emphasizes passenger comfort, safety, accessibility, and operational efficiency. Now the connectivity. Connectivity includes well connected to city center and major highway via road networks linked with public transport, taxis, buses and app-based cab services for passengers' convenience. International and domestic flight connect the airport to Middle East, South Asia and major Indian cities. Serves as regional hub for tourism business and media travel. The impact on the region boost the regional economy by promoting tourism, trade and international businesses, supports employment generational in aviation, hospitality, transport and service sectors, facilities, media, medical tourism and educational travel, improving regional accessibility, enhances infrastructure development in surrounding areas, including roads, hotels, and urban facilities. Future expansion plans to increase passenger and cargo handling capacity with terminal expansion, development of new taxiways, aprons, and parking to reduce congestion, incorporate of advanced technology for aircraft management, security, and passenger services. It focuses on sustainability, including energy efficient systems, runway harvesting, and green building practices. The final conclusion is it serves as major gateway connecting Kerala to domestic domestic and international destinations. It plays a vital role in regional economic growth, tourism, and trade. Modern design and infrastructure ensure safety, efficiency, and passenger comfort. The future expansion plans to aim to enhance capacity, integrate technology, and promote sustainability acts as a model case for case study for airport planning, terminal design, and airside operations. Thank you, sir.
Okay, good. Next.
Good morning, sir. I am Rahul Port, roll number 46. So, sir, topic I choose is culvert. Basically, culvert is a small cross drainage structure that allows water to pass under a road, railway, or embankment. It basically maintains a natural flow of water without disturbing a traffic movement. Uh, it basically prevents water accumulation, road damages, soil erosions, and flooding in the various areas. Basically, the location of the culvert can be specific culverts are placed near major drainage paths, small streams, rivers, its location depends on the catchment area. The area of culvert are depends on the rainfall intensity, catchment area, runoff area, peak demand, erosion, uh, are there are basically three types mainly.
स्क्रीन स्क्रीन पुन्हा प्रेझेंट कर आणि थोडा रेंजमध्ये ये.
Okay, sir.
Yes.
So, sir, the type of culverts are it can be basically classified on the basis of shape and material. There are three types: pipe culvert, box culvert.
प्रेझेंटेशन आहे ना, ओपन दिसत नाही, लगेच गायब होत आहे.
सर प्रेझेंटेशन केलेलं आहे म्हणजे शेअर केलेलं आहे.
बरं, म्हणजे शेअर केला असेल आणि मग ओपन असेल तर दिसायला पाहिजे. मग
सर मग स्क्रीन दिसत नाही का?
थोड्या वेळापुरती दिसते आणि परत जाते. मग दिसते.
Sir, basically the first type of the culvert is pipe culvert. As the name suggests, it is basically in the circular shape, made up of RCC steel or HDPE, used for small discharge, and it is economically feasible and easy to install. Secondly, box culvert. It is rectangular in shape, suitable for medium discharge, strong and durable, acts as a rigid frame structure, and mainly used in highway and urban areas. And last but not the least, slab culvert, simply simple RCC slab used for very small drainages, low cost and easy construction. Uh, at last, the culverts are used for drainage systems, and a proper location is needs to be determined for their installation. Waterway calculation is also essential. Uh, that's all, sir. Thank you.
ओके, गुड.
सर करू का मी प्रेझेंटेशन सुरू?
हो.
तर दिसते स्लाइड?
हो, तुझं नाव आणि रोल नंबर सांग.
ओके सर, स्वराज ठोरे, रोल नंबर 53.
Yes.
Good morning everyone. My name is Swaraj, and Today I'm going to present a topic before you. So the topic I got for seminar analysis has a landmark infrastructure to instruct engineering lessons for long span design and supports superstructure planning. Objectives of this seminar is to compare structural systems, load transfer materials, construction challenges, and practical design significance for advanced civil engineering practices. So the case study we are going to look in today is the Golden Gate Bridge. The Golden Gate Bridge is a classical suspension bridge with main cables, suspenders, towers, deck truss, and massive anchorages. Load path, which is deck, then suspenders into main cables, which are distributed in towers and anchorages. Key point, which is that the flexible global system that provides efficiency for its 1,280-meter main span and notable seismic performance and considerations. Materials and challenges. The primary material is structural steel and selected for which is selected for high strength to weight and ductility. Construction challenges included strong currents, deep water foundations, high winds, and involving seismic design and requirement. The engineering lessons we are getting here are competitive lessons highlighting the long span design strategies, load path clarity, and material selection for durability, which emphasizes the redundancy, maintainability, and seismic reliances in bridges. The second one is the Dubai International Airport. The structural terminal layout is the prioritizes wide column free concourses, long span roof base, and clear passenger flows, in which the structural grid uses large span trusses and transfer elements to accommodate MEP, glazing, and future expansions. Superstructure materials. The primary materials here are structural steel for long span trusses, reinforced concrete for foundations and cores, and pre-stressed element for continuous slabs. Composite systems used to optimize weight, stiffness, and constructability. Phased construction and extensive logistics planning are critical for minimal operational disruption, address climatic effects, which are thermal expansion, corrosion, heavy foundation loads on reclaimed soils, and construction for large MEP systems. Conclusion of this PPT and slideshow is the both case studies demonstrate the importance of tailored structural systems, suspension mechanics for bridge spans, and integrated truss and concrete systems for airport roofs. Key takeaways are the match materials to span and man function, prioritize load path clarity, and design for durability, maintainability, and constructability.
Okay, Swaraj. Good. ऑडिओ ऑन करा, नाव रोल नंबर सांगा आणि मग पीपीटी शेअर करून स्क्रीन शेअर करून पीपीटी ओपन करा.
येस सर. होती का माझी स्क्रीन शेअर सर?
हा होते. पीपीटी ओपन करा.
ओके सर. सर स्क्रीन शेअर होतीये?
हो हो.
ओके. Good morning, everyone. My name is Trupti More, roll number 37, and my topic is Pune International Airport. First, introduction of Pune International Airport. The Pune International Airport is important in Maharashtra. It serves both domestic and international flights. It plays a key role in connecting Pune with major cities in India and abroad. The importance of Pune International Airport. It supports IT industry, education, and business sectors, boost tourism in Pune and nearby regions, improve the regional and international connectivity. The locations of Pune International Airport as located as Lohagaon, Pune, around 10 kilometers from Pune city center, well connected by road and public transport. The history of Pune International Airport, later development for civil aviation, uh, originally established as a military air base, op- operated jointly by Airports Authority of India (AAI) and Indian Air Force. The destination and passenger facilities. Destination domestic Delhi, Mumbai, Bangalore, Chennai, Hyderabad, and Kolkata. The international has Dubai, Abu Dhabi selected the flights, and the passenger facilities are waiting lodges, food courts and restaurants, duty free shops, medical assistant, and budget handling the services. Terminal informations of Pune International Airport, single integrated terminal for domestic and international passengers, modern infrastructure with passengers friendly facilities, capacity to handle millions of passengers annually. Future development of Pune International Airport, proposed new international airport at Purandar, expansion plans to reduce congestion, improve passengers handling capacity. And my second seminar topic is effective weight and design loads for bridges. Then introduction of bridges. Bridges are designed to safety carry traffic and environmental loads. Proper loads distribution is essentially for safe and economical design. Concepts like effective width and design loads help the engineer achieve this. Then effective width is the portion of bridge's deck slab that effectively resists bending due to the applied loads. It represents how loads distributed transversely across to the deck. And need effective width loads does not act only at a point, it spreads across the slab. Help simply analyze to deck the slab. Then factors affecting the effective width: span length of bridge, type of loading, positions of load to the dig, type of bridges, T-beam, slab bridges, etc. Then the effective width as per IRC. Then IRC provides the formula for calculating the effective depth. Depends on span length, width of carriageway, load position used mainly for the deck slab design. Then introduction to the design loads. The design loads are force considered during the bridge design. Bridges must resist the traffic loads, environmental loads, self weight of structure. Then types of design loads: dead load, live load. Third is impact load, wind load, seismic load, and water and temperature loads. Then the dead load and live loads are: the dead load is the self weight of bridges components, and the live load are load due to moving of vehicles and pedestrians. Then impact load and wind load. Mostly impact load is additional load due to dynamic effect of moving vehicles, depends on span length, type of bridges, and reduce increase in span. Wind load acts horizontally on bridges structure. Importance of long span. Importance of long span, high piers considered as IRC guidance. Then seismic load, loads due to earthquake force, depends on seismic zone, mass of structure, importance for bridges in earthquake. Thank you, sir.
Okay, good.
सर स्क्रीन शेअर झाली का?
हो.
पीपीटी दिसते.
दिसतंय दिसतंय.
Good morning, all of you. I'm Shura. I'm 57. Talking my airport. छत्रपती
थोडा आवाज
शिवाजी
कमी येतोय बरं का. आवाज कट होतोय. थोडं रेंज मध्ये येता आलं तर बघ.
हॅलो.
हा येतोय आवाज. बोल.
The introduction of this airport, Chhatrapati Shivaji Maharaj International Airport, is one of the busiest airport in India and serves as the primary international gateway to Mumbai, formerly known as Sahar International Airport, handles domestic and international air traffic, operated by Mumbai International Airport Limited, known for modern terminal design and efficient infrastructure. Second one is location and site characteristics. Chhatrapati Shivaji Maharaj International Airport is strategically located in the Andheri area of Mumbai, one of the most densely populated urban regions in India. The airport serves as the primary aviation hub for the Mumbai metropolitan region. Location details: situated approximately 8 km north of South Mumbai, well connected by Western Express Highway, suburban railways, and metro lines. Uh, Next one is site characteristics. Total land area of about 750 hectares, located in a highly congested urban environment. Limited scope for horizontal expansion due to surrounding development. Requires vertical terminal expansion and optimized land use planning. Next is runway system. Chhatrapati Shivaji Maharaj International Airport has two intersecting runways, primary runway and secondary runway. Now second one is engineering aspects, asphalt and concrete pavement. Second is designed for wide body aircraft, advanced runway lighting and marking. Next one is terminal buildings. There are two terminals, Terminal 1 and Terminal 2. Terminal 1 handles domestic flights, earlier terminal with renovated facilities. Terminal 2 handles international and domestic flights. uh, Iconic architecture inspired by Indian peacock, G plus 4 structure with long span roofing system. Second one is structural and architectural features, large span steel roof trusses, earthquake resistant RCC
स्क्रीन
structure.
गेली बरं का.
स्क्रीन दिसत नाही का?
हा पुन्हा रिशेअर कर एकदा. Yes.
Okay.
Continue.
Structural and architectural features, large span steel roof trusses, earthquake resistant RCC structures, use of glass for natural lighting, efficient load distribution for heavy passenger movement, design as per ICAO and Indian standards. Second one, apron and taxiway system, concrete apron designed for high wheel loads, multiple aircraft parking bays, rapid exit taxiway, reduce runway occupancy time, proper surface drainage system. Second one is sustainability and safety measures, rainwater harvesting, energy efficient lighting, noise monitoring system, continuous pavement maintenance and inspections. Conclusion: the Chhatrapati Shivaji Maharaj International Airport is a major international airport located in a highly congested urban area. The airport is well planned with efficient runways, terminals, and taxiways, limited land availabilities, Terminal 2 shows modern structural and architectural design with safety and durability. Proper drainage, pavement design, and safety system help handle heavy traffic and monsoon conditions. Chhatrapati Shivaji Maharaj Airport is an important example for understanding airport engineering principles in real life conditions. Thank you, sir.
Okay, good.
सर मी शेअर करू का?
हो.
स्क्रीन दिसते का?
प्रेझेंटेशन ओपन कर.
केले ओपन सर.
हा दिसेल.
सर स्क्रीन दिसतेय का?
ॲट अ टाइम वन बघा कोणीतरी तुमच्यातलं ठरवा आणि दिव्या प्रेझेंट करते ऑलरेडी आय थिंक. अंकिताने शेअर केले आता.
अंकिता तू पहिलं कर. मी करते.
बरं ठीक आहे. हो. Good morning, sir. My name is Ankita Shinde. My roll number is 58. In this presentation, I will explain introduction history, importance of bridge, engineering aspects, material use and maintenance and conclusion. Introduction. The Godavari Bridge is an important bridge built across the Godavari River. It helps in transportation, connects in different regions. Historical background. The original bridge was called by the Havelock Bridge. It was built during the British period and opened in 1900. Then talking about its construction, the bridge was built to improve transportation across the river. Engineers used advanced techniques to overcome challenges like strong water flow. Regional connectivity. The bridge improves connectivity between nearby regions. It helps people travel easily and support transportation of goods. Then talking about the economic impact, the bridge supports economic growth and trade. It helps tourism and improves people access to markets and services. Then engineering aspects, the bridge is designed to carry heavy loads. It uses strong foundations and structures to reduce water currents and other forces. Then design and materials. The bridge is made using steel and concrete. These materials provide strength and durability. Also, the maintenance and upgradation of efforts. The bridge requires regular inspection and maintenance. Engineers repair and upgrade parts to its safe. Then challenges faced and solution implemented during the Godavari Bridge. It is located in the Andhra Pradesh. The challenges engineer faced is like floods and soil erosion. They solved these problems using strong foundations and better materials. Then talking about the conclusion of Godavari Bridge. To conclude this, the Godavari Bridge is an important in engineering structures. It improves transportation and supports regional development. Thank you for listening my presentation. Thank you.
Okay, good.
Sir, screen is visible.
Yes.
Good morning, everyone. My topic name is Bandra Wall Sea Link. Introduction. Bandra Wall Sea Link is a cable-stayed bridge
Tell
in
your
Mumbai.
name and roll number.
My name is Suhani Kare. Roll number is 29.
Okay.
Introduction. Bandra Worli Sea Link is a cable-stayed bridge in Mumbai. Offices name
Screen
Rajiv
गेली
Gandhi.
बरं का परत.
स्क्रीन दिसत नाहीये का सर?
परत रिशेअर कर.
सर आता दिसते.
हो.
Introduction. Bandra Worli Sea is a cable stayed bridge in Mumbai. Office name Rajiv Gandhi Sea Link. It connects Bandra it's in western suburb in Worli in South Mumbai. One of the India's most iconic infrastructure projects. Location located over Mahim by Urban Sea, part of Western Freeway Sea Link projects. Reduce travel time between Bandra and Worli. Bandra Worli Sea Link, a need for the sea link, heavy traffic congestion in Mohim causeways, long travel time during peak hours, need for the fast, safe, and reliable transport route to improve connectivity in Mumbai. Basic details: length is 5.6 kilometer, width is 27.2 meter. Lanes there are the 8 lanes, 4 plus 4. Type of cable is cable stayed bridge. Speed limit is 80 kilometer per hour. Construction details: construction started in 2000, open for the public. Completion for the project is 2009. uh, Construction cost approximately 1 crore 600 lakhs. Constructed by MESRDC. Engineering challenge: construction over open sea, environmental concerns, strong tides and monsoon conditions, traffic management and during construction. Structural features: cable stayed design with steel cables, pre-stressed concrete segments designed to withstand earthquakes, strong winds and sea waves. Thank you, sir, for
Good.
Sir, screen is visible.
Yes.
Sir, my name is Sir. Screen is visible.
हो हो दिसतंय.
Sir, my name is Viraj Sawan. Roll number 9. Introduction to aircraft characteristics related to aircraft airport design characteristics of principal transport aircraft trend size. Introduction. Aircraft characteristics refer to the physical performance and
एक
optional
मिनिट
features of
स्क्रीन शेअर तू केलेली आहे का वैष्णवीने केली बघा आणि दोघांपैकी एक जणांनी स्क्रीन शेअर करा बरोबर पीपीटी.
केले ना सर मी.
हा ठीक आहे. तुझा रोल नंबर किती?
9. Roll number 9.
कंटिन्यू.
Those characteristics play a major role in planning and design of airports. Different type of aircraft have different requirements for runway length, width, and pavement strength. The size and weight of aircraft affect taxiway layout, operate size, and hangar design. Passenger and cargo capacity influence terminal planning and airport capacity. Working principle: an aircraft operates based on the principle of aerodynamics. Lift is generated when air flows over and under the wings, creating a pressure difference. The shape of the wings causes faster airflow over the upper surface and slower airflow below. According to Bernoulli's principle, lower pressure above the wing and higher pressure below produce lift. Newton's third law also contributes. The wings pushes air downward and air pushes the aircraft upward. Thrust produced by engine moves the aircraft forward. Once a lift is generated the wings, the aircraft takes off. Characteristics: runway length and strength depends on aircraft weight and performance. Taxiway and apron size depends on aircraft dimensions. Terminal capacity depends on passenger and cargo capacity. Safety clearance depends on wingspan and tail height. Advantages of aircrafts: fastest mode of transportation over long distance, saves travel time and passenger and goods, can access remote, high level of comfort and safety. Disadvantages of aircraft: high operating and maintenance cost, requires expensive airport infrastructure, limited carrying capacity compared to ship, affected by weather condition, causes noise pollution near airport. Applications: passenger transportation for domestic and international travel, cargo and freight transport for fast delivery of goods, military applications such as defense, surveillance, and combat, medical and emergency services include air ambulances, aerial surveying, and mapping. Conclusion: aircraft characteristics play a crucial role in airport planning and design. Understanding the working principle and types of aircraft helps in efficient airport operations. Principal transport aircraft determining runway length, pavement strength, and terminal capacity. The trend round larger and more efficient aircraft includes modern airport infrastructure. Proper consideration of airport characteristics ensures safety, efficiency, and economic operations of airport. Thank you, sir.
तर मी करते आता प्रेझेंटेशन.
ओके.
झालं. बरोबर बोलतो.
Divya, mic
तर
on.
दिसते का स्क्रीन?
Okay, okay, yes.
My name is Divya Nalte, roll number 82. My topic name is Pune International Airport. Abstraction major public airport at Lohgaon. Importance evidence hubs in Maharashtra. Support IT, tourism, and education of business. Operation by AAI and Indian Air Force. Introduction: one of the biggest airport in Maharashtra. Importance for the regional connectivity. Support economic growth. Historical background: original in military air base, later started civil operation, modernization improved facilities. Location and importance: located by at Glogaon, 10 kilometers from city. Support IT industry and tourism. Importance for educational section. Infrastructure: modern passenger terminal, runway handle Airbus A320 and Boeing 737, basic passenger amenities available. Operational statistics: handle million of passenger annual, increasing aircraft movement. Connectivity: connected to Delhi, Mumbai, Bangalore, Hyderabad. Good road connectivity. Passenger service: clean terminal, sitting arrangement, drinking water, information task. Security and safety: security by CISF and Indian Air Force. CCTV surveillance, emergency support system. Economic impact: boost employment, support tourism, help industrial growth. Challenge: limited space congestion, few international flights. Future development: terminal expansion, new routes, smart airport technology. Conclusion: key aviation hub in Maharashtra, support economy and connectivity, future growth potential. Thank you, sir.
Okay. कोण देणार आहे प्रेझेंटेशन फिक्स करा.
हॅलो सर, स्क्रीन विजिट का?
करण.
हो. येस सर. सर स्क्रीन विजिबल आहे का?
ओके. हो.
सर सर, माय नेम इज काळेकरण, रोल नंबर 25.
ओके.
Junction of flexible and introduction in highway engineering traffic in highway engineering different types are based on soil condition. rigid concrete and
आवाज कट होतोय करण जरा.
rigid pavement distribute will load over a large area due to its high stiffness. Flexible pavement transfer load layer by layer using higher deformation compared to rigid pavement. At a junction, transition zone is provided to balance the difference in load transfer behavior. Advantages: provide smooth transition between two different pavement types, reduce stress concentration and the meeting point, minimize bumps and differential settlement, improve rigid comfort and vehicle safety. Disadvantages: require careful design and detailing. Improper construction can cause crack and uneven settlement. Higher initial construction cost is at the junction. Need skilled workmanship for proper load transfer device. Applications at entry and exit point of cement concrete roads. On highway where pavement type change due to traffic or soil condition. Near toll plaza and near toll plaza and check post at bridge and flyover approach road in urban roads where rigid pavement meets bituminous pavement. Conclusion: the junction of flexible and rigid pavement is a critical transition zone in highway engineering. Due to different structural behavior, improper junction design can lead to crack bumps and uneven settlement. Providing a gradual change in stiffness and effective load transfer ensures smooth performance. Thank you.
ओके करण.
Yes, sir.
नेक्स्ट.
कोण आहे?
सर स्क्रीन विजिबल आहे का?
हो, प्रेझेंटेशन ओपन कर. येस.
Hello. I sir visible.
हो, रोल नंबर सांग तुझा.
Uh, Good morning, everyone. I am Saira Sajan Shetty, roll number 50. My topic for today is temporary bridges. Introduction. Bridges are civil engineering structures that provide passage over obstacles such as rivers, valleys, roads, and railway lines. They ensure connectivity of transportation and connectivity depending on their period of use. Bridge may be permanent or temporary. Temporary bridges are connected to meet short-term requirements. Overview. Temporary bridges are designed for a limited duration of services. They are simple in design, quick to construction, economical, and can be dismantled and reused after completion of work or emergency situations. Definition: a temporary bridge is a structure constructed for short term uses to provide access across an obstruction. It is commonly used during construction activities, repair works, emergency, or military operation, and is not intended for long term heavy traffic. Need for temporary bridges. Temporary bridges are required to maintain traffic flow during repairs or construction of permanent bridge. They are also essential during flood, natural disaster, and emergency situations. In addition, they are widely used for military and strategic purposes. General requirement for temporary bridges. Temporary bridges must have adequate strength to carry expected load and sufficient stability against wind and water forces. They should be easy to erect and dismantle, economical in design, and safe for use during their service period. Material use. The selection of material for temporary bridges depends on its span, load, duration of use, and availability.
Material should allow rapid construction and easy handling while ensuring sufficient strength and safety. Some materials are timber, which is widely used in temporary bridges due to its easy availability and low cost. It is lightweight and easy to handle and requires minimal equipment for construction and makes it suitable for short-term bridges. Some examples are given below. Next material is steel. It is also a commonly used material in modern temporary bridges system. It provides high strength and durability and carry heavier loads compared to timber. Steel bridges are reusable and suitable for multiple projects. Example: other material used in bridges include aluminium, which is lightweight and corrosive resistance. Rope and cable are used for suspension and arcing, while bolt and fastener are used for connection. Uh, Pontoons or boats are used for bridges. Floating bridges. A floating bridge or pontoon bridge is supported on floating pontons, which may be a boat or hollow steel units. The bridge deck rests on its floating support, and no fixed foundation is required. Use of Proton bridge. They are used where river depth is large or the riverbed is weak. They are widely used in military operations and are specially useful during flood or emergency situation where quick bridge construction is required. Conclusion: temporary bridge plays a vital role in civil engineering by providing quick and economical solution for short-term needs. Photon bridge are the most commonly used types, and proper planning ensures safety, efficiency, and reliability. Thank you.
Okay, Sairaj.
सर स्क्रीन शेअर केले दिसते का?
हो हो. रोल नंबर नाव.
वैष्णवी दंडनाईक, रोल नंबर 77.
ओके.
Today I am going to present this uh, airport classification. Introduction: airports are classified to ensure safe and efficient aircraft operation. Classification helps in planning, design, and operation of airports. Geometric standards depend on type and function of airport. Functional classification of airports based on purpose and type of air traffic determines facility, runway length, and infrastructure. Main functional type: international airport, domestic airport, regional airport, general aviation airport, military airports. Type of functional classification: international airports, domestic airport, regional airport, general aviation airports, military airports. International airports serve international air traffic equipped with customs, immigration, and quarantine. Long and strong runways for large aircraft. Domestic and regional airport. Domestic airports handle national flights. Regional airports connect small cities and towns. Limited facility and moderate runway length. General aviation airports used for training private and charter flights. No scheduled commercial service, short runways, and basic facility. Military airports used for defense and air force operation, designed for specialized military aircraft. High safety and security measures. Some are civil military shared airports. Uh, Airport classification for geometric standards based on aircraft size and performance. Standards recommended: International Civil Aviation Organization, Directorate General of General Civil Aviation, Federal Aviation Administration, used for designing runways, taxiways, aprons, and clearance. International Civil Aviation Organization, Aerodrome reference code and conclusion consist of code number plus code letter, code number, runway length, code letter, wing span, and wheelbase. Proper classification ensures safety, uniformity, and efficiency. Thank you, sir.
Okay.
Rule number 77, sir.
Yes. Who is next?
पीपीटी ओपन कर लो पीपीटी सर स्क्रीन दिसतीये
हो.
myself sir Prachi Somanshi roll number 59 introduction air transportation is the fastest mode of the transport the importance of economy development and tourism the airports require the proper planning and design the civil engineers is ensure the safety and efficiency the importance of air transportation is support the trend and the tourism, reduce the travel time, and the essential for the defense and the emergency. The geographic distribution and overview, uneven distribution across the world depend on the economy and the population. Regulated ICAO and IATA content the distribution and North America highest traffic. Europe is a dense airport network. Asia is the fastest growing region. Africa and South America development network. The factors affecting the distribution, the economic development and the population density, tourism and trade, the climate and airport layout, civil engineer review, runway, taxiway, aprons, and terminal buildings, and the control tower. Characteristics of a good airport layout, the proper runway and orientation, and the runway length, the efficient taxiway system, and the safe and smooth operations. The civil engineering requirements, the strong pavement and design, proper drainage and system, uh, obstruction-free approaches, and the provision for the future expansion. Conclusion: air transportation is the vital globally, and the airport planning and depend on the geography. And a good layout ensures safety and efficiency. The civil engineers play a key role. Thank you, sir.
Okay.
Roll number 59.
Yes. Okay.
Okay, sir.
Who is next? देणार आहेत का प्रेझेंटेशन कोणी पंकज सूरज
येस सर सूरज मस्कर सर आवाज येतो
हो
स्क्रीन शेअर करू का
हो
सर स्क्रीन दिसते?
Oh, yes.
Good morning, sir. Good morning, everyone. My name is Suraj Santosh Maskar. My topic is the design of pipe culverts and design of box culvert. Culvert design, ensuring safe and efficient water flow. Culverts are vital for infrastructure, allowing water to pass under roads, railway, and embankments. Proper design is crucial for stability, longevity, and environmental protection. Next, understanding culvert types. There are two types: pipe culverts and box culverts. Pipe culverts are typically circular to elliptical, made from materials like concrete, corrugated metal, or plastic, often used for smaller flows and shallower installations due to their inherent structural efficiency. Box culverts, rectangular or square, usually constructed from reinforced concrete, ideal for larger flows, uh, higher fields, and situations requiring more structural rigidity, often offering a better hydraulic efficiency for certain conditions. Pipe culvert design considerations. There are three considerations: hydraulic capacity, structural integrity, and environmental impact. Hydraulic capacities, sizing the culvert to efficient convey peak water flows, preventing upstream flooding and erosion. Consider inlet and outlet control conditions. Next, structural integrity, ensuring the pipe can withstand external loads from soil, traffic, and internal water pressure. Material selection and bedding are critical. Environmental impact, minimizing disruptions to aquatic ecosystems and ensuring fish passage where necessary. Sediment transport and water quality are also key. Next, key design parameters for pipe culverts. Several factors influence the performance and durability of pipe culverts. Diameter and length, slope, material, inlet and outlet configuration. Next, box culvert design considerations. Box culverts offer robust solutions for larger flows and demanding structural requirements. Their design involves the comprehensive analysis for various factors like load analysis, structural analysis, hydraulic performance, foundation design. The advantages of box culverts: high load capacity, superior hydraulics, longevity, and wildlife passages. Material selection, pipe versus box. The choice of culvert material is critical and depends on the several factors like concrete, durable, strong, and widely available, excellent for both pipe and box culverts. Corrugated metal, lightweight, flexible, and cost effective for pipe culverts, available in various coatings for corrosive and resistance. Uh, Plastic, corrosion resistance, lightweight, and smooth for pipe culverts, offering good hydraulic properties. Next, environmental impact and mitigation. Culvert design must address potential environment concerns to minimize ecological footprint and promote sustainability. Uh, Fish passage, wildlife connectivity, water quality. Next, construction and installation best practices. Proper construction and installation are as vital as design for culvert longevity, such as site preparation, bedding material, backfill and compaction, and quality control. Conclusion: integrated culvert solutions, effective culvert design, whether for the pipe or box configurations, requires a holistic approach, integrating hydraulic structure and environmental considerations. By adhering to best practices, we ensure resilient infrastructure that protects both human development and natural ecosystem. Thank you.
Okay, good, Suraj.
Thank you, sir. Sir,
Pankaj.
roll number 79.
Yes. पंकज तुझा काय नंबर आहे? पंकज तुझा रोल नंबर?
78, sir. Hello, sir.
हां. 78, ओके. पीपीटी ओपन कर. हो.
Hello. Sir,
Yes, yes, yes. Start. Oh.
Sir, good morning, sir. Good morning, everyone.
My name is Pankaj Umbarkar. My topic is runway design for lane and related correction and features of essential runway marking. Runway design for lane and marking. Ensure safety and precaution. Clear wheel proportion. Runway are the foundation of safe operation. This bridge cover the lane, wind and marking geometrical interact and shows practical correction for narrow runway with sketches of essential marking. Why runway length and marking matter? Safety and performance. Runway length determine available takeoff and landing distance for vary aircraft weight and environmental condition. Visualization gradients. Marking provide the pilot primary visual for alignment and aiming point and touchdown, essentially in reduced visibility. Key, key factors in runway lane design. Prevailing wind, crosswind, aircraft performance, terrain and land. Wind affecting runway length. 30 meter wind inches on a 30-meter runway can overlap. That overlap may create aiming point, merge through shore and edge strips and provide misleading later especially in low visibility and during high speed workload approach. ICAO AOE recommendation correction for narrow runway. Essential runway marking and over view and functions. Center line, three shore, aiming point, touchdown zone, age marking. Thank you, sir. Hello.
Okay. हाँ.
हाँ सर.
Yes. Okay. So हम करना रहेगा presentation. So हम
हेलो सर.
हाँ presentation करना रहेगा.
नाही सर, लिंक शेअर होईल, पीपीटी ओपन होईल.
Presentation करणार आहे का आता?
पीपीटी ओपन होणार सर.
बरं ठीक आहे, परत सांग मग.
हो. तर नंतर गेली तर
बघू परत. ओपन झाल्यावर सांग. Okay, students. So in yesterday's lecture, we have revised some of the topics from the syllabus. Now we'll see one of the previous question paper, that is from November 2025. So you can see the questions based on the theory which or concept which we have studied. Question number 1, this is from unit number 3. Explain the need of building information modeling for airport BIM. So questions are straightforward from the syllabus. What is aim of airport drainage? Give functions of the airport drainage. So you have to explain how drainage is important, or considering urban flooding, how you can provide good drainage facility at the airport and keep airport working during the rainfall, maximum rainfall, or when the city gets flooded. That time, that particular airport facility will be available for emergency operations or disaster management. So we have discussed. Next question is, what is ultimate and practical runway capacity? Give factors affecting the runway capacity. Runway capacity is nothing but the number of flights attended in a particular time. So ultimate, what is ultimate, practical, that we have seen in our theory. Then what are the benefits of BIM modeling for airport? So in advance, we can visualize the components, we can make corrections, walk through, like feel we can take. Write a short note on virtual reality. So augmented reality and virtual reality, there is slight difference. You have to understand what is difference between them. Then give classification of airport pavement and explain in detail. So rigid pavements and flexible pavements. Then what are the different factors that affect the airport lighting? So how the lighting, or basically what is the purpose of lighting, and further you have to explain different factors that affecting the airport lighting. Means what is the need, how we can provide the lighting, and on which factors the lighting of the airport is dependent. Then write a short note on airport marking. What are the different types of marking? We have seen how they are read and what is their significance. Then explain in brief heliports and stolport. So we have to describe what is difference between heliport or stolport, even how airports and heliports are different. So heliports are facility provided for the landing and takeoff of helicopters. Then write short note on making of heliports, lighting of heliports. Likewise, airports, heliports also can be lightened, or light facility marking will be done. What are the different characteristics of STOL aircraft? STOL and VTOL, these two terminologies are important. Short takeoff and landing, vertical takeoff and landing. How to plan stall ports, give advantage of STOL aircraft. Now you can see a number of airport infrastructure facilities during this war situation also. Give brief classification of different bridge structures. How bridges are classified? What are the different components of bridge? Explain in detail with the help of neat sketch. Wherever possible, draw proper sketch that will explain the concept in short. What is economic span of bridge? Give derivation for economic span of bridge. What are the different types of culverts? Basically, you have to understand what is the difference between culverts and bridges. Under culvert, you will see box culvert, pipe culvert. Explain in detail with the help of neat sketch. Sketch is very important and very much needed. What is causeway? Explain the different types of causeway with the help of neat sketch. So in this particular topic, that is bridges and culverts, you have to remember different types, where they are used, and why particular type of bridge is used at that particular place, considering economy, topography, need, budget, we can say. So explain preliminary and detailed survey work to be done before construction of bridge structure. Give explanation on direct method of calculating maximum flood discharge. So while providing passage under the bridges, we have to consider maximum flood going to happen at that place. So these are the hydrological calculations. Based on such calculations, numericals are there. Explain in detail movable span superstructure with the help of neat sketches. Sketch is very important everywhere. Explain cutboard bridge, flying bridge, lift bridge and swing bridge with the help of neat sketches. So this is particularly the question paper. Then we can see some of the solutions to these questions.
Airport and bridge engineering. Q1. A. Need of BIM for airport. Building information modeling, BIM, is essential in modern airport engineering due to the complexity, scale, and multidisciplinary nature of airport projects. Airports include runways, taxiways, terminals, drainage, lighting systems, and navigation infrastructure, all of which must function in coordination. BIM provides a digital model integrating architectural, structural, and operational data into a single platform. This allows engineers and planners to visualize the airport before construction, detect design conflicts, and optimize layouts. BIM improves coordination among different stakeholders such as civil engineers, electrical engineers, planners, and contractors. It reduces errors, rework, and construction delays, thereby saving time and cost. It also helps in accurate quantity estimation and cost control. Another major benefit is life cycle management, where BIM assists in operation, maintenance, and future expansion planning of airport facilities. Additionally, BIM supports simulation of traffic flow, aircraft movement, and emergency scenarios, enhancing safety and efficiency. It also promotes sustainability by optimizing material use and reducing waste. Thus, BIM is a powerful tool that ensures efficient planning, construction, and management of modern airports. Q1. B. Aim and functions of airport drainage. The main aim of airport drainage is to efficiently remove surface and subsurface water from airport areas to ensure safe aircraft operations. Water accumulation on runways and taxiways can lead to hydroplaning, skidding, and loss of control, making proper drainage a critical safety requirement. The functions of airport drainage include rapid removal of stormwater from pavements, prevention of water stagnation, and protection of subgrade soil from saturation. Drainage helps maintain pavement strength and prevents structural damage such as cracking or rutting. It also reduces erosion around airport infrastructure and ensures longevity of pavements. Drainage systems consist of surface drains like side drains, inlets, and channels, as well as subsurface drainage systems that remove water from beneath pavements. Proper drainage design also helps in flood control and ensures uninterrupted airport operations during heavy rainfall. Additionally, it contributes to environmental protection by safely conveying water away from sensitive areas. Overall, airport drainage plays a vital role in maintaining safety, durability, and efficiency of airport operations. Q1. C. Ultimate and practical runway capacity. Ultimate runway capacity refers to the maximum number of aircraft movements, takeoffs and landings, that can be handled on a runway under ideal conditions without considering delays. It assumes perfect weather, uniform aircraft types, and highly efficient air traffic control. Practical runway capacity, on the other hand, is the number of aircraft movements that can be handled with acceptable delays under real operating conditions. It considers factors such as weather variations, aircraft mix, pilot behavior, and operational constraints. Practical capacity is always lower than ultimate capacity. Factors affecting runway capacity include runway configuration, single or multiple runways, air traffic control efficiency, spacing between aircraft, navigation aids, and weather conditions such as visibility and wind. Aircraft characteristics, including speed and size, also influence capacity. Understanding both capacities is important for airport planning, expansion, and scheduling. It helps in designing runways, managing traffic efficiently, and minimizing delays. Proper capacity analysis ensures optimal utilization of airport infrastructure while maintaining safety and efficiency. Q2. A. Benefits of BIM for airport. BIM provides numerous benefits in airport engineering by enhancing planning, design, and construction processes. One of the major advantages is improved visualization through 3D models, allowing stakeholders to clearly understand the layout of airport facilities. This reduces design errors and improves coordination among various disciplines. BIM enables clash detection, where conflicts between different systems such as structural, electrical, and plumbing are identified early, avoiding costly rework. It also improves project scheduling through 4D modeling and cost estimation through 5D modeling, leading to better project management. Another benefit is enhanced communication among stakeholders, as all information is stored in a centralized digital model. BIM also supports life cycle management, helping in maintenance and operation of airport infrastructure. It promotes sustainability by optimizing resource usage and reducing waste. Additionally, BIM helps in risk analysis and safety planning by simulating different scenarios. Overall, BIM increases efficiency, reduces cost, and ensures better quality in airport projects. Q2. B. Short note on virtual reality. Virtual reality, VR, is a technology that creates an
Wait for
immersive
some
digital
time.
environment,
Don't present
allowing
now.
users to experience and interact with simulated surroundings. In airport engineering, VR is used for visualization, planning, and training purposes. VR enables engineers and planners to virtually walk through airport designs before construction, helping them identify design flaws and improve layouts. It enhances understanding of spatial relationships and improves decision-making. VR is also useful for training airport staff, including pilots, ground staff, and emergency responders, by simulating real-life scenarios. It improves safety by allowing testing of emergency situations without real risk. VR also enhances passenger experience by simulating terminal layouts and crowd movement. It helps in optimizing design for comfort and efficiency. Overall, VR is a powerful tool that enhances visualization, planning accuracy, safety, and operational efficiency in airport engineering. Q2. C. Classification of airport pavement. Airport pavements are classified into two main types: flexible pavements and rigid pavements. Flexible pavements consist of layers of asphalt and granular materials. Load is distributed gradually to the subgrade. These pavements are economical, easy to repair, and suitable for moderate loads. Rigid pavements are made of cement concrete and distribute loads over a wider area due to their high stiffness. They are more durable and require less maintenance but have higher initial cost. Flexible pavements include surface cores, base cores, and sub-base layers. Rigid pavements include slabs, joints, and reinforcement. Selection depends on traffic load, soil conditions, and economic considerations. Both types are designed to withstand heavy aircraft loads and ensure safety and durability. Q3. A. Factors affecting airport lighting. Airport lighting is influenced by visibility conditions, weather, runway layout, and aircraft operations. Factors include fog, rain, and night operations which require high-intensity lighting. Runway length and width determine lighting arrangement. Type of aircraft and approach speed also affect lighting design. Maintenance and power supply reliability are important factors. Proper lighting ensures safe landing and takeoff under all conditions. Q3. B. Airport marking. Airport markings are visual aids provided on runways, taxiways, and aprons to guide pilots. These include center line marking, threshold marking, touchdown zone marking, and edge marking. Markings are done using white or yellow paint depending on the area. They help in navigation, alignment, and safety. Proper marking reduces confusion and improves operational efficiency. Q3. C. Heliport and STOLport. A heliport is a facility designed for helicopter operations including landing and takeoff. It requires smaller area compared to airports. STOLport is designed for short takeoff and landing aircraft. Heliports are used in urban areas, hospitals, and remote locations. Stallports are useful in hilly and constrained areas. Both improve accessibility and reduce infrastructure requirements. Q5. A. Classification of bridge structures. Bridges are classified based on function, material, and structural system. Based on function: road, railway, pedestrian bridges. Based on material: steel, concrete, timber. Structurally: beam, arch, suspension, cable-stayed bridges. Each type is selected based on span, load, and site conditions. Classification helps in proper design and selection. Q5. B. Components of bridge. Bridge components include superstructure, substructure, and foundation. Superstructure consists of deck slab, girders, and trusses. Substructure includes piers and abutments. Bearings connect superstructure to substructure and allow movement. Foundations transfer loads to ground. Each component plays a crucial role in stability and load transfer. Q5. C. Economic span of bridge. Economic span is the span length at which total cost of bridge is minimum. It depends on cost of piers and superstructure. As span increases, number of piers reduces but superstructure cost increases. Economic span is obtained when combined cost is minimum. It helps in cost-effective bridge design.
Okay. Who want to present? Anyone left for presentation? Tushar?
सर ओपन झाले PPT.
सोहम.
सर करू अभी पीठ भेजेल त्याची.
हो हो. सोहम रोल नंबर काय तुझा? सोहम रोल नंबर काय?
रोल नंबर 8 सर. 8.
ओके स्टार्ट. स्क्रीन गेली बघ परत.
हॅलो.
येस. ओपन द प्रेझेंटेशन. सोहम प्रेझेंटेशन दिसत नाहीये. मिनिमाइज करायचं आणि पीपीटी ओपन करायची डायरेक्ट.
तसंच करतोय सर.
स्क्रीन शेअर करून मग ते गायब होते परत. स्क्रीन शेअर ऑन ठेवायचं आणि पीपीटी ओपन करायची मिनिमाइज करून. मीटिंग मिनिमाइज करायची. दुसऱ्या विंडोमध्ये लेफ्टला पीपीटी ओपन कर डायरेक्ट. स्लाइड कर. आता प्रेझेंटेशन चालू आहे थोडक्यात तुझं, बरोबर आहे. आता तुला फक्त हे मिनिमाइज करायचंय किंवा स्लाइड करून पीपीटी ओपन करायची. डायरेक्ट पीपीटीवर जायचं. इथून गायब होते बरं. कर ओपन केली का पीपीटी आता तू? पीपीटी दिसत नाही तुझी मग. तुषार करतोय का तू?
दिसतंय.
नाही ना, ते नेमकं स्क्रीन शेअर केल्यानंतर परत तुझं पीपीटी गायब होते लगेच. स्लाइड कर फक्त स्लाइड. मल्टिपल टॅब आपण स्लाइड करतो ना तसं.
सर आता है का?
ठीक है, स्टार्ट कर. स्क्रीन शेअरिंग स्टॉप होते तुझं.
आता दिसतंय का सर?
जाऊ दे, तोच प्रॉब्लेम आहे. तू कंटिन्यू कर. हा, बोल. दुसरं कोणी आहे का प्रेझेंटेशन करणारं? सोम बोलतोय का? Okay, let us stop now. We will meet again. Bye.